In the last lecture, you saw how we used interfaces to improve the testability of our application. In this lecture, we're going to see how interfaces help with extensibility of our application. So similar to the last lecture, we are not going to have any slides here. So let's jump into Visual Studio and start coding. Okay, let's say we would like to create a tool for migrating a database. We can start by creating a class called dbMigrator. This class can have a single method called migrate, which can be void. And here we're going to have details of migrating the database. Now, to keep things simple, I'm not going to implement that here. But what I want to show you is how we can create extensibility points here by using interfaces. For now, let's just assume that we would like to log some messages on the console as the database is being migrated. For example, we may want to display the time the migration started. We may display the time migration finished. If there were any problems along the way, we can display them on the console. So one way to implement something like that is to go here and say console.writeLine migration started at, and here we can have the current date time. Potentially we can have another console.writeLine here to indicate where migration finished. Now the problem with this kind of implementation is if tomorrow we decide to use a file or a database instead of the console, we have to come back to this method and change it, which means this class has to be recompiled and redeployed. Let me tell you something interesting here. In an ideal world, we would like to design our software such that we can change its behavior without changing its code. You might wonder, how is that possible? Well, it is possible by using extensibility, which means instead of changing the code in the existing classes, simply add in new classes that change the behavior of the system. With this way of thinking, every time we want to change the behavior of our software, we create new classes, and as you learned from the last lecture, we can write unit tests or any kind of automated tests only for those new classes. The impact should be minimal to zero on the existing classes because we are not changing the existing code. Now, as much as this idea sounds beautiful, sometimes it's a little bit costly to implement. So, in practical terms, we cannot design software such that every change can be implemented using an extensibility mechanism. Well, it is possible, but sometimes the cost of that is way too much and it's really not worth it. But in this case, in our dbMigrator, it is possible that someday in the future, we may decide to log messages in a file or in a database, as opposed to a console. So how can we design this dbMigrator such that it's extensible? Well, that's by using an interface. Let's see how we can make this happen. So instead of using the console directly here, we should use an interface like Logger. Let's create an interface for that first. So public interface iLogger. Note that I'm prefixing that with capital I. Now a logger may provide methods like log error, which gets a message, or another method like log info, which is for simply logging information messages which are not for reporting problems in the code. It's purely for troubleshooting. Let's put this interface in a separate file to clean up our code. So back here, Alt and Enter, Enter. Okay, now back to the program. And I'm going to do the same thing with dbMigrator. I'm going to put it in a separate file. So Alt and Enter, Enter. Now we want to change dbMigrator to get an iLogger interface. So as you learned in the last lecture, we need to create a constructor here. And in the constructor, we inject that interface. So iLogger, we call it logger. And with ReSharper, we can press Alt and Enter here when the cursor is on the logger here. And Enter again. And ReSharper automatically creates a private read-only field of type iLogger. So the technique we're using here is called dependency injection, which means in the constructor, we are specifying the dependencies for this dbMigrator class. And later in the main method, as you will see shortly, we're going to specify a concrete class that implements that interface. So this whole thing is called dependency injection. Now, in the migrate method, instead of directly talking to the console, we're going to talk to a logger. So say logger.loginfo, and I'm going to cut this message here and paste it here. Except that I need to change this comma to plus because I have to concatenate them to form a string, whereas in the console of the write line, we were passing multiple arguments. Let's remove that. And I'm going to repeat the same thing here. This time I change started to finished. Again, to refresh your mind, remember the analogy I used for the restaurant. I said the restaurant needs a chef. Now, whether that chef is John or Steve or Mary, it doesn't matter as long as that chef has some capabilities to a given standard. It's the exact same scenario here. So DB Migrator doesn't care who's the actual logger. An instance of any class that implements this interface can be passed in the constructor here. So there is no coupling between DB Migrator here and that concrete class. Now let's create a concrete class that implements that interface. So public class, let's call it console logger because we use console for logging. iLogger, not the red underline, that's because we have not implemented the interface yet. So we press Alt and Enter and Enter. Now here I'm using ReSharper, so it opens up this dialog box which allows me to choose which methods I would like to implement. And by default, both of them are checked. If you don't have ReSharper, I think Visual Studio automatically implements all methods in the interface. So let's just go with the defaults. So for login error, I'm just going to use console.write line and pass that message here. And to make it a little bit more user-friendly, we can perhaps change the color of the font. So say console.foreground color equals console color dot red to indicate an error. We can repeat the same thing in the loginfo method, and instead of using red, we can use, say, green. Now let's put this class in a separate file. Okay. Let's take one final look at DB Migrator. So look, it knows absolutely nothing about the console, and it's just talking to an interface. Now let's go to the program. In the program, we're going to create an instance of DB Migrator. So var DB Migrator equals new DB Migrator. In the constructor, I need to specify a concrete implementation of that iLogger interface. In this case, we pass a console logger. And finally, we call the migrate method of the DB Migrator. Let's run the application. There you go, we got two messages on the console. Migrate, sorry for the spelling, it's migrating, started at, here's the date time, and we had a problem here with the formatting of string. It doesn't really matter. And you see the second message, migrating finished at the date time. Now let's say that hypothetical scenario is going to happen. So we decide instead of logging messages on the console, we decide to log them in a file. Let's see how we can achieve that. So all we have to do is create a new class, public class file logger. It implements the iLogger interface, and we repeat the exact same steps here. So Alt and Enter again, and again. We got these methods here. So let's create a constructor that takes the name of the file. So ctor, maybe a path is better. And now we press Alt and Enter and again. So we got the private field here. And in the log error method, we need to create a stream writer for writing data to a file. So new stream writer. Note that this class is defined in system.io namespace as you see here. And because I'm using ReSharper, ReSharper automatically added the using namespace for me here. So it makes your life much easier. Back here. Now in the constructor for stream writer, I need to specify the path. So I use that private field. And the second argument specifies whether we would like to append to that file. Of course, yes. Then we can call the writeLine method and pass that message here. There is just one problem here. The problem is that this stream writer uses a file resource. A file resource is not managed by CLR or Common Language Runtime, which means we need to dispose that resource once we finish using that. The easiest way to do that is to wrap this whole block here in a using statement. So let's see what happens. I move this var stream writer inside using. And then in the using block, I move this stream writer.writeLine here. Basically, what happens behind the scene is there is an exception handling mechanism inside this using that you're not going to see. It's implemented by the compiler. So if something goes wrong, an exception is thrown or something, the compiler will make sure to close the file handle by calling the dispose method on the stream writer. Let me show you that method here. So stream writer.dispose. This method is used for freeing external resources that are not managed by CLR. When we use the using statement here, the using block, the compiler automatically includes a call to the dispose method, so we don't have to manually do that. Okay, one last thing here. Perhaps it's a better idea to add a prefix string here to specify that this is an error, because when working with a file, we don't have colors like as we did with console. So we can say error plus message. We could potentially include the date time here as well, but it doesn't really matter for the purpose of this lecture. Now, interestingly, we need the exact same code for the loginfo method here. But look, we're duplicating code, and there is a principle called dry, or don't repeat yourself. So we can refactor this and make it a little bit better. What we can do is we can create a private method, call it log. It gets a message and perhaps gets another string like message type. Let me scroll down so you can see this a little bit better. And then I'm going to move all this code inside this method. Instead of using this hard-coded error prefix here, I'm going to use message type plus colon and a space. And then I'm going to reuse this method in both log error and log info methods. So see, there's no code duplication anymore. So I'm just going to call log, pass the message, and the message type is going to be error. And we do the exact same thing here with log info. Now, even a better way to do this is to use an enumeration. So you should be familiar with enumerations, but again, I leave that to you as an exercise because I don't want to get too distracted with best coding practices in this lecture, because we just want to see how we can use interfaces to create extensibility points in our application. So I think for now, that should do the job. Let's put this class in a separate file. So I'll put the cursor here, Alt and Enter, and Enter. Good. Let's review what we have done so far. So back to our program. See, we created a DB migrator and passed a console logger instance to its constructor. And finally here, we called the migrate method. Let's take a look at DB migrator. So DB migrator talks to an interface. It doesn't know what concrete class is going to implement this interface. It doesn't really care. Now at this point, when we run the application, messages are logged on the console. We can change the behavior of the application by simply going to the main method and swapping that implementation with a different implementation. So instead of console logger, I'm going to use file logger. Specifying path. So I'm going to use // say log.txt. Actually, this may throw an exception on my machine because I'm running this in a virtual machine and I don't think there's access to the root of C drive. So I'm going to change the path to projects / log.txt. Let's run this. Note that no messages are logged in the console anymore. Let me go to the file system. So C drive, projects, look, we have a log file here. So info messages are logged in this file. You see there are 4 of them because I ran the application twice in the middle of recording. So don't worry about that, there is no bug. The first one says migration started, migration finished, and then here we ran the application again, so we got 2 more messages. So the interesting thing here is we changed the behavior of our application by simply creating a new class, as you saw here, file logger, and simply passing that to this constructor here. I did not change one line of code in DB Migrator. And this is what we call changing the behavior by extending the application instead of changing the code. In object-oriented programming, this is referred to as open-closed principle or OCP, which states software entities should be open for extension but closed for modification. And in practical terms, that means here, this class should be closed for modification. We didn't change anything here, but this is open for extension using this extension point. Now, don't think that you always need to use an interface in scenarios like from console to file system or from file system to database. Not necessarily. That was just a simple example. In your application, you might have an application that is working on a map, like a GPS application, like Google Map, and you need to calculate the shortest distance between 2 points. You can use an interface like Route Calculator that finds the shortest path between these 2 points. Later in the future, you may come up with a better algorithm. Maybe an algorithm that is faster, maybe an algorithm that knows the traffic conditions, or whether a street is 1 way or 2 ways. You can simply create a new implementation of that interface and inject that to your class without changing the existing code. Or let's say, as another example, in your application you have some kind of encryption. Maybe you have a class that needs to use an encryption service. So in that case, you can create an interface called iEncryptor and create a class that implements that interface with a very basic encryption algorithm. Later in the future, you may come up with a better algorithm, a better encryption algorithm. Then you can simply change the behavior of your application by creating a new class that implements that interface. So you got the point. Well, that's pretty much it for this lecture. I hope you enjoyed it and thank you for watching.